Hey everybody, this is Michael Parent with Michael Parent Consulting Services. Today I just wanted to talk a little bit about one of the statistical distributions we use oftentimes to model service operations. In traditional manufacturing, we don't really worry about too much of our statistical distributions. If we ever do some kind of advanced modeling, like a Monte Carlo simulation, we'll oftentimes use a normal distribution to talk about things like quality and cycle times and things like this, to say it's going to vary more or less on a centered point of the process, and then it's going to be symmetrical. We're going to have some that meet our cycle time standard, some that exceed our cycle time standard, and some that perform better than our cycle time standard. But oftentimes when we talk about service environments, we don't have processes that really exhibit a normal distribution. That is, what we see usually is that it follows this thing that we call gamma distribution. And here what I want to do is just talk about what a gamma distribution looks like, and why really it's advantageous to use it when modeling service environments. So as you can see here, the gamma distribution takes two parameters, an alpha and a beta. And what it looks like, if I put in alpha of 2 and beta of 2, we see that it has this curve here from a probability standpoint, and then it has this very, very long right tail, right? It's skewed very far right. And we can say that this is really indicative of a lot of processes that, if we're looking at wait times or processing times of working with a call center environment or something like that, we might say that, look, the probability of getting things done relatively quickly is fairly high, but then there's this potential for it to drag on further and further and further. Anybody who's stood in a line for a bank teller or something knows that generally we can get to the bank teller relatively quickly, but sometimes if it's a Friday afternoon and everyone got their paycheck, we'll see that this tail extends out further and further. And this is really indicative of service processes as well, is it's bounded at 0, right? I can't have a negative processing time. Whereas in a traditional manufacturing setting, I may have something that is negative to the spec. If we center whatever that specification is at 0, we can have things that go negative. It's minus 1 millimeter to spec, plus 1 millimeter to spec. So we can see here that the gamma distribution does a really good job of really just showing what that process would look like from a service perspective. And then if we change these parameters, I'll show you what it looks like. We change these parameters, we see that this left side then gets more of the probability distribution. As alpha goes up, we hit 7 here, we can see now that it's starting to get more normal, still skewed right, to be sure, but now a lot of the probability is hitting on the left side of the median average or the mean average, excuse me. But if we go back to 2, this is usually what I use to model different processing, different service distributions. And then of course, if we change beta, what we'll see is this tail on the right side extends much, much longer. So you can see here that we were at about 20, I changed beta to 7, and now we're way out at 50. If I change it to 10, and we can see that this tail gets longer and longer, but also that our probabilities still kind of converge in that 10-minute mark. So just, again, a helpful distribution when talking about and modeling different service level probabilities. In a subsequent video, what I'll do is I'll show how I use this to model operations in a Monte Carlo simulation for a call center environment.